So what we're looking at now is the ring trap for the ion trapping labs, one of our ion trapping labs, and you can see there is a copper ring inside this box, and the ring is displayed on the monitor over here. You can see the camera in the back, and we can twirl the ring around, and the inner diameter of that ring is about 16 millimeters, so that'll fit on your little finger without too much trouble. Okay, and there it sits. So now what we do is we turn this on, and we sort of bathe it in laser light. This is a green laser pointer over here. It shines down on the ring. Okay, so the ring's still there. Okay, and so there it is. Now what we're going to do is put the high voltage on the ring. So we'll turn that up to a couple thousand volts AC. Then we take this wand, and the first thing we do is made of Teflon, and we charge it up a little bit, just have to rub it a little, and that charges the Teflon. Then we dip it in a speaker, pick up some particles. These are lycopodium club moss particles. They're about 25 microns in diameter, fairly spherical, and all about the same diameter, 25 microns. Now they're all charged up, and we got the voltage on the ring, so we just bring this in here. And you ought to be able to see some of the particles on the monitor over there. Okay, there they are, trapped ions. Okay, it's hard to see in this video, so let's bring you in a little bit closer. So hang on. So now you're looking right at the monitor, and there are the charged particles. Okay, we can move the ring around still, and you see them moves the particles as well. And if you're looking carefully, you see the particles look like little streaks. And the reason for that is that they're being shaken by those 60 hertz fields. Okay, and so we can see that more clearly if we put a strobe on the laser. So now we're going to turn that laser on and off at about 60 hertz, a little off of 60 hertz. And so now you see, since the laser pulses on and off, we're strobing the illumination of those ions, so we can slow down their motion effectively. We can change the frequency of that, like so. Make it faster or slower. All right, and that shows the micro motion, the 60 hertz motion. So we're strobing the laser close to 60 hertz. And you can see the particles going back and forth. If we change the trap parameters a little, we can move them around. We can rotate the ring. See them going up and down. Lost a few there. Okay. Air currents will also distort the cloud a little. It's very sensitive to air currents, so everything's fairly open now, so we do have some air currents on there. Okay, so we have a couple of variables we can change here. Let's just turn the strobe off, and we see the particles floating around. You see them moving a little in the air with air currents. So we have a number of things we can do. One is we can change the AC voltage. We can turn it down, the trap gets looser. We turn it up, it gets tighter. And there's also a DC voltage we can use to put a static force on the ions. Basically counters gravity. So if we turn that all the way down like it is now, the particles will be fairly low, and the trap, if we turn it up, then we push them up. You can see that easier if we turn the ring on its side. So we turn the DC voltage up, we can see the particles trying to escape to the top, and we turn it down and they'll start to poke out the bottom a little bit. Can't see it too much here. So basically the DC voltage will allow us to essentially change gravity. Okay, so we can make the particles float or sink a little bit, depending on the DC. So we've got the AC and the DC, and we can twirl the ring around a little just to see the geometry and all of these things. We can add more particles if we want. Let's turn this up. I'll show you what I mean. We can put a lot of particles in there. We turn it up, and we just put this here and add particles as much as we want, really, and we can get a pretty sizable pretty sizable collection of particles in there. Okay. So there we see a big cloud of atoms, or ions, not atoms, they're 25 microns. Just oodles of particles. Again, we can see them. If I turn the DC voltage up, they seem to float up the top. If I turn it down, they'll start to fall out the bottom, and I'll lose them. So I can just move it up and down by changing the DC voltage. I can change the AC voltage, turn the trap down a little bit, and they start to get a little wider. If I turn it up, they get a little tighter, and we can spin the ring around and see this way. Okay. The particles repel each other because they're like charge. So you get what's called a Coulomb crystal. There's a few things in there that are kind of composite particles. And so they will all repel each other as well. We can turn this down and see they tend to want to avoid each other. You can put a smallish number of particles in the trap. There we have, let's see, how many do I count? 8 particles in the trap, 9. 9 particles in the trap now. And if I want to move them up, I can move them up with the DC voltage or down, like so. And can move them, twirl it around. It's very dynamic, as you can see. The air currents push them around, and the electric fields push them around. Gravity is pulling on them. The forces involved, for gravity, for example, if you calculate the force of gravity, it's like 10 piconewtons. And so the very, very tiny forces one is dealing with, and yet you can easily see the effects of these small forces on these very tiny particles. Okay, so a lot of the experiment is just trying to see how this works and studying a little bit about the dynamics of the trap and seeing how the particles interact. Okay, and you'll notice that they do repel one another. Their forces, the trapping forces, want to push the particles to the center of the trap, but at the same time they all have like charges, and so they repel one another, and so they try to avoid each other. There's the micromotion that gives them their streak-like appearance, and if we put the laser strobe on again, we can see them see the micromotion directly. Okay, and there's gravity pulling them down as well. And finally, they're sort of oozing around just because of air currents, because things are fairly open. We can close the box a little more and reduce those air currents. So there you have it, ion trapping in a nutshell. It's very easy to do. These particles are very easy to trap. The trap is very trouble-free. It just works. And it's really just a lot of fun to play with. Okay, and it demonstrates some fairly interesting physics. So there you have it, the ring trap, which is one of the traps in the electrodynamic ion traps experiment by Newtonian Labs. So if you want to see more, I hope you look around the website some more, newtonianlabs.com. Thanks for listening.